Grab a shiny metal spoon and look into the bowl. You'll notice your reflection is looking back at you entirely upside down. If you flip the spoon over, you're suddenly right side up again, though your face looks strangely stretched and shrunken. These two shapes have specific names. The caved inside is a concave surface, and the bulging back is a convex surface. A flat mirror reflects light in a straight line for a perfect image. But when we bend that wall, we change how the light has to behave. The reason a spoon warps your image is that a curved surface physically reroutes the path of the light rays hitting it. On a flat surface, light bounces off at a predictable, straight angle. Visualize these angles with a flat foam piece and straight pins. Each pin represents the path of reflecting light. When we bend the foam inward to create a concave shape, the geometry shifts. Now all those pins are forced to point toward each other. They all meet at one specific point of intersection, known in physics as the focal point. This is exactly how light behaves. When parallel rays hit a concave mirror, they bounce and meet at that one spot. That meeting point is incredibly powerful. As this diagram shows, a concave mirror can gather sunlight and focus all its heat into a single, intensely bright spot that can actually burn paper. Because they collect and concentrate light into one point, concave mirrors are the ultimate tools for focusing energy. If we bend the surface the other way, pushing it outward to create a convex shape, the reaction changes completely. Our foam metaphor shows the angles reversing. Instead of meeting, the pins spread apart and face away from each other. This is scattering. When light hits a convex mirror, the rays bounce away from each other in different directions. By scattering light, the mirror can gather images from a much wider angle and squeeze them into your eye. You see a much larger area, even if the objects in the reflection look smaller. These are widening tools, giving up the true size of an image to provide a much larger field of view. Using these rules, we can see why looking into the bowl of a spoon turns us upside down. Because a concave curve forces light to the focal point, the rays actually cross over each other. The light from the top of your head keeps traveling downward after it crosses, while the light from the chin goes upward. This geometric crossing is what flips your reflection. If your eye is positioned past that focal point, you are seeing the top of your head at the bottom of the image. These physical behaviors allow us to use mirrors as specialized tools in our daily lives. When we need to see a wide, sweeping area, like a security mirror in a store, or a side view mirror checking a highway blind spot, this is why we use the scattering power of convex surfaces. Look at this satellite dish. When we need to capture a weak, scattered signal from space, we use a massive, concave shape to catch those waves and focus them into one strong, readable point. Curved mirrors are geometric tools. By bending light, we can expand our vision and harness energy to solve real-world problems.